RHS Pre-Calculus presents Aviation Buggy. Our goal is to solve an aviation math problem.
Buggy is a bug. He's a very fat and gluttonous bug. Recently, he's eaten all the leaves around his home. So he decides to pick up roots and head somewhere else. He sets a course due south, where he has heard the leaves are tastier. On his way, he encounters an evil wind, blowing from due west, who wants to make trouble for Buggy. Buggy gets knocked off course. Now Buggy is lost. Fortunately, he has stunning pre-calculus skills and can use aviation to figure out what his new course is. Ha! Take that, evil wind. To figure out his new direction and speed, Buggy is going to use a coordinate graph labeled like a compass rose, with north, pointing up, followed by east, south, and west. An object's course is measured in degrees, with 0 degrees being with north and moving clockwise. Buggy is moving due south, which is 180 degrees from north.
Buggy knows he was flying due south at 120 knots, and because his right side is still sore from the impact, he knows the evil wind hit him from due west at 160 knots. So now, because the wind came from the west, Buggy's course was pushed, so now it is somewhere eastward.
Oh look, we've created a triangle. Let's enlarge it.
We want to find Buggy's new speed and his new angle. Looks like a side angle side situation. To find his speed, that side length, we are going to use the law of cosines. For a triangle with angles A, B, and C, and side lengths A, B, and C, the formula is a squared equals b squared plus c squared minus 2 times b times c times cosine of angle A.
As you can see, we placed in 120 for B, 160 for C, and 90 degrees for angle A. After solving this equation, we find out that Buggy's new speed is 200 knots. Now, we need to find theta. Can you guess what formula we're going to use?
Law of sines. Law of sines states the side length A divided by a sine of angle A equals side length B divided by a sine of angle B, which equals side length C divided by a sine of angle C.
Using this triangle, we put in place 200 for side length A and 90 degrees for angle A, and 160 for side length C, and we are solving for angle C.
With quick work of the calculator, it turns out to be 53 degrees. Let's go back to the compass. We now know Buggy's speed and this angle. Since from here to here is 180 degrees, if we subtract 53 degrees from 180, then we find Buggy's new direction.
It's 127 degrees.
So where and how fast is Buggy going?
200 knots with a course of 127 degrees.
Yay.